All right, kids, we are taking a trip. We're going to Petropavlovsk. I'm going to do this right. Petropavlovsk Kamchatsky. And that is a place in Russia, right here, off the Sea of Okhotsk, where the temperature is on average 273 Kelvin or 0 degrees Celsius, and the average pressure is 1 atmosphere. So basically, this is the place where standard temperature and pressure exists. And it's a lovely place. It's a fishing area. You can see here some lovely pictures of it's a volcanic island. It's in the Ring of Fire. So this is kind of a cool picture where all this uh, cloud sort of settled in on the city. All right, so we're gonna get rid of the music. So only there are any of these things helpful, but we teach you that at STP, 1 mole of gas equals 22.4 liters, and that's just the thing. And it's helpful if you live here. If you don't live there, rarely do you do things at STP. So it's more of just a ballpark figure. Like if you need a mole of gas, you're like, oh, well, it's about 22.4 liters. That's what it does. So keep in mind, this is at 273 Kelvin and 1 atmosphere or 760 millimeters of mercury. Um, it's always going to equal, regardless of the gas, it's going to be 22.4 liters. So it doesn't matter if it's helium, doesn't matter the size or the mass of the gas, it's always 22.4 liters. All right, so if I ask you how many moles of chlorine are there in 25 liters, you would say, all right, well, there's 25.0 liters. And since it's at STP, I know that there are 22.4 liters for every 1 mole. And then you can find out that the answer is, hold on a second while I get rid of my dancers from Russia, 25 divided by 22.4, 1.11, 1.12 moles. Okay. So liters cancels and you got moles left. How many grams are in 14.5 liters? Same situation. Since it's at STP, you take the 14.5 liters. You know there's 22.4 liters for every 1 mole. That'll give you the moles. All right, so 14.5 divided by 22.4, 0.647. But then this is looking for grams, and hopefully you remember that the periodic table, right, gives grams to moles. So we got to go, I should have sang the whole thing, but I didn't. So carbon is 12 and hydrogen is 1, basically. So you're going to have 2 carbons. There's 2 carbons with a mass of 12. And hydrogen, there are 6 hydrogens with a mass of 1 for a grand total of 30. So there are 30 grams in 1 mole. So if you need to find grams, you multiply that by 30 and you get 19.4 grams. All right, so it allows us to bring that periodic table grams to moles situation back. But this is only useful at STP, which isn't terribly useful. All right, so some other manipulations we do at STP is to find the density. Now, to define the density, if we ever ask you the density, you just take the mass and divide it by 22.4 liters, because the units of density for gases is considered grams over liters, and that's because the density of gases is significantly less, right? If you have a gas, the gas is significantly less dense than, where is it? There it is, right? Than a solid. So if you had a solid, it would be much more dense. So we do grams per mil or grams per centimeters cubed. But since it's a gas, we do grams per liters. So basically, you just need to find the grams and divide it by that 22.4 because these questions, again, are at STP. So N on the periodic table is 14 For its mass, it's number 7, but it's 14. And oxygen on the periodic table is number 8, and its mass is 16. So we're going to have, and the mass. So for nitrogen, there's 1 atom, and the mass is 14. For oxygen, there's 2 atoms, the mass is 16. That's 32, that's 14, and we add that up, and you get 646 grams in 1 mole. But it doesn't matter because we're just going to take the 46 grams and divide it by the 22.4 liters. And that's how you do it. 2.05 is the density. All right. So we also do stoichiometry at STP. So the steps for that are whatever is given in liters, you'll divide by 22.4 to figure out the moles. Then you'll use the balanced equation to do the mole to mole, right? So in this case, we're going from oxygen, right? We're going from oxygen to nitrogen. All right. And then you'll multiply back by 22 to get the liters usually. I mean, but you could do anything, but typically this is how this is asked. Again, any of these calculations are only good if you live in Petrovsk, Petrovsk, Kamchatsky, because this is only at STP that any of this is any good. All right, so we're given 1.78 liters of oxygen. So 1.78 liters of oxygen, and then you want to know, well, how many moles is that? Well, there's 22.4 liters in 1 mole, right? So that'll give us moles of oxygen, 1.78 divided by 22.4. So that's 0.0795, 795 moles of oxygen. And then we want to go from moles of oxygen to moles of nitrogen. So we want to go, we're going to use that balanced equation that there are 3 moles of oxygen for every 2 moles of nitrogen. And then after that, we want to know the liters, right? It asks for liters. What volume? Yeah. So then we need to go back to liters after that. But anyway, that'll give us moles. So that times 2 divided by 3, 0.0530, 0.0530 moles of N2. And then to get to the liters, we're just going to multiply that by the 22.4 liters in 1 mole, which is 1.19. All right. So that's that for stoichiometry. Now, keep in mind what drives me nuts about this is, and the reason I taught you, PV equals nRT is a very useful equation to know. Anytime you need, that's sort of like the tool that works all the time. This is really just a shortcut for STP only. But PV equals nRT would have given you all the answers you just got, plus more, because if the temperatures or volumes or pressures change, then you can use PV equals nRT to figure out moles. But this is just a shortcut for STP, and that's all we're going to be doing on this test is STP. So let me do one more of these. So if you have 0.855 liters of oxygen, okay, it's at STP, so you know you can do this thing. So 0.855 liters of oxygen. You got to go from liters to moles. And then you can use this thing, the balanced equation, that 5 moles of oxygen will give you 4 moles of NO. And then we also know that for every 1 mole of NO, you have 22.4 liters. And so everything cancels here, nicey nice, right? We got rid of liters oxygen, we got rid of moles oxygen, we got rid of moles NO, and we're up to liters again. So you just multiply the tops times 4 times 22.4. So the tops are 76.6. 76.6 divided by 22.4 times 5, which is 112. And so you get an answer of 0.684 NO.